Hello there and welcome to A2 Maths. We're on Specimen Paper 1 and here we're looking at question 9, a differentiation from first principles question. So before we get started, let's just remind ourselves what the differentiation from first principles formula looks like. It's lim as h tends towards 0 of f of x plus h minus f of x over h. Okay, and the equation that we're doing this with is y equals 2x cubed plus 5. We want to work out the value of the gradient of the tangent at the point 1, 7. Okay, so what we could do then is we could work this out differentiation from first principles in general first and then plug in 1, 7 afterwards, or we could plug in the 1 to start with. It doesn't really matter which way you do it. I'm just going to work it out in general first, just as a reminder of how we do that. So you could plug in the 1 as well. That'd be perfectly great as well. So f of x plus h. F of x is this expression here, so it's just going to be x plus h, where that cubed expression is there. So it's x plus h, all being cubed, plus 5. Minus 2x cubed plus 5. So the 5 is going to disappear from the top very, very quickly. Let's expand what we now have on the x plus h all cubed. Now, if you remember from the binomial expansion coefficients go 1, 3, 3, 1. So it's going to be 2x cubed plus 6x squared h plus 6x h squared plus 2h cubed, and then we're going to plus the 5, but we've got a minus 5 inside there, and in fact we've also got a minus 2x cubed, so that one there can disappear as well, and then we're left with this fraction here all over h. So now let's divide everything by h. They all have h's in them. So it's going to be 6x squared plus 6xh plus 2h squared. And now what we're going to consider is the limit as h tends towards 0. So as h gets really, really small, this bit here effectively will just get really, really small because it's being multiplied by h. This bit here will get really, really, really small because it's multiplying by h squared. The only bit that doesn't really change is this 6x squared because it isn't affected by the size of h. So the answer here is just 6x squared. If we want to work out the gradient at the point 1, then this gradient is just going to be 6. So therefore, the equation of the straight line, because that's what we're trying to work out here, we're trying to work out the gradient of the tangent, is going to be the value 6. So in general, the formula to work out the gradient was 6x squared, but at the specific point of 1, the gradient there was 6. We didn't need to go and find the equation of the tangent. I thought we did, but we actually don't need to, which is fine. So there we are, that's question 5 done for us there. Hopefully, when you're in the exam, you can get these ones done really quickly, 5 marks. You definitely don't need 5 minutes to do this. Get it done, get it out of the way and done with. Use the binomial expansion shortcut to get these expressions here, and then the question is pretty straightforward. So there we are, that's question 9. Let's now move on to question 10.